Hello class. Today we're going to be talking about circle proofs. So if you could take your note packets out to the first page that says circle proofs, this is where we will begin. Example 1 says, given line segment AE is congruent to BE, can you prove that arc AC is congruent to arc BD? Now the way we prove arcs are congruent is first we need to know that their chords are congruent. So we're going to have to prove chord AC is congruent to chord BD. Well, the only way we know how to prove two line segments are congruent is to use CPCTC. So it looks like we're going to be doing a triangle proof. So let's go ahead and tee off our proof, and we can start with our given. So AE is congruent to BE as your given information. Now be sure above the letters that you mark whether or not they're line segments or they're arcs. In this unit in particular, we're really going to need to pay attention to, are we given information about arcs or are we given information about line segments? So you really need to make sure you're labeling your letters correctly. So here above the AE and the BE, I've labeled it with line segments. So now I can mark my picture, AE, congruent to BE, by putting hash marks. Now let's look to see if there's any other angles or line segments we can prove are congruent. So I'm seeing AEC is a vertical angle with BED, so I'm going to mark those angles and put that in my proof. Angle AEC is congruent to angle BED using vertical angles are congruent. Now I need another pair of sides or angles in order to do a triangle congruency proof. So I'm looking at this picture, and what you need to recognize is angle A and angle B are actually both right angles. And the reason why they're both right angles is because they're inscribed angles. And if you look at their intercepted arc is that semicircle, which means their angle's half of 180 degrees. And half of 180 degrees is 90 degrees. So both angle A and angle B must be 90 degrees. So I'm going to say angle CAD and angle DBC are right angles. And the reason, angles inscribed in a semicircle are right angles. Well, now if we know they're right angles, we know they're congruent. Angle CAD is congruent to angle DBC because all right angles are congruent. We now have our three congruency statements, which means I can now write my triangle congruency, which states triangle AEC is congruent to triangle BED because of angle side angle. And now we can use our CPCTC to say side AC is congruent to side BD. And again, that's by CPCTC. Well, our prove statement says we need to prove those arcs. So my last step will be to say arc AC is now congruent to arc BD. And that's a new reason. That reason says if two chords are congruent, then the corresponding arcs are congruent. So that's if two chords are congruent, then their corresponding arcs are congruent. So if you know the chords are congruent, their arcs become congruent as well. So what we've done is we've used two brand new reasons in our proof. And those two reasons were in step 3 and step 7. So maybe you want to make a list of reasons you can use in circle proofs. And some of the new reasons that you might not be familiar with are going to be step 3 and step 7. And you can list those and maybe reference back to those when you're trying to do circle proofs on your own. Let's go on to question number 2. Question number 2 says, if line segment AB is congruent to line segment EB, can you prove arc AM is congruent to arc MB? So again, let's use another triangle proof here. So I'm going to go ahead and tee off my proof. And my given is that AE, and again, don't forget the line segment above it, is congruent to EB, with a line segment above it, as your given information. And now I'm going to go ahead and mark that in my picture. If you can see the two triangles you're trying to prove, maybe you can now notice that AO and OB are both radii, which means they would have to be congruent as well. So now I can say AO is congruent to OB, and that reason is going to be radii of the same circle are congruent. Make sure you don't just say all radii are congruent. Make sure you're saying all radii of the same circle. So showing that you're inside the same circle, you know that all those radii are congruent. So now I can use the reflexive line with OE and say OE is congruent to itself, OE, by reflexive property. And now I have my 3 congruency statements, so I can talk about my triangles. Triangle OEA is congruent to triangle OEB using side, side, side. Well, once the two triangles are congruent, I'm trying to get the arcs AM and arcs MB congruent. But we don't have chord AM and chord MB like we did in the last proof. So here's what we can do in this proof. I can say now that the triangles are congruent, it is true to say angle AOE is congruent to angle BOE, and I can say that by CPCTC. And if those two angles are congruent, notice that those two angles are central angles. So both of those angles are central angles. That means the arcs across from those central angles will also be congruent. So now I can end my proof and say arc AM is congruent to arc MB. And here's the reason we can write. If two central angles are congruent, then the corresponding arcs are congruent. So again, some new reasons we've used in this proof come from step number 2 and step number 6. So those are going to be some new reasons, again, you might want to jot down for some future proofs that you might have to do on your own. Okay, we can go on to the next page. Let's skip example number 3 and go to example number 4, continuing with our triangle proofs. So example 4, I'm going to go ahead and tee off. List my statements and reasons at the top. And we are given that BC is congruent to AD. And again, I'm going to put those line segments above it. And that's your given information. So let's go ahead and mark those. Those are some chords. And now we need to continue on getting 2 more congruency statements in order to end our triangle proof. So I bet you're starting to see your vertical angles. We can mark those. Make sure you're not just calling them angle E. We have to say angle AED is congruent to angle BEC. That's because vertical angles are congruent. And now we need either another angle or another side. So here's what we're going to do next. Angle A and angle B are actually both congruent to each other. That's A and B. Here's why. Angle A and angle B are both inscribed angles. And we know that inscribed angles are 1/2 of their intercepted arc. Well, if you look across from angle A, the intercepted arc would be arc DC. So angle A would be half of DC. Looking at angle B's intercepted arc is also DC. So angle B would also be 1/2 of DC. So they're both 1/2 of the same angle. So those 2 arcs would be congruent. So that's what I'm going to do next in my proof. Say angle DAE is congruent to angle CBE. And here's the reason I'm going to use. Inscribed angles that intercept the same arc are congruent. So if you have 2 inscribed angles that are both across from the same arc, then those 2 angles are congruent. Well, now I can end my proof. We can say triangle ADE is congruent to triangle BCE, and my reason is by angle, angle, side. Great job. All right, let's look at the next page. And the next page, we are going to do example number 5. So example 5 says, we need to prove chord AB is congruent to chord CD. So the way we're going to do this is show, because I don't have triangles, so I can't do a triangle proof, I'm going to show that first arc AB is congruent to arc CD. Because we learned from our first proof, if the chords are congruent, then the arcs are congruent. And we can also work backwards. If the arcs are congruent, then the chords are congruent. So let's start this proof here. So the given information says CB is the diameter of circle O. Another given says AB is parallel to CD. Now, knowing that we have parallel lines, we learned a property that says, given that you have two parallel lines, we can show that the arcs are congruent, and the arcs inside the parallel lines are the ones that are congruent. So I now have arc AC congruent to arc BD. And the reason is parallel chords intercept congruent arcs. But those are not the arcs that I want. I want the other arcs, AB and CD. But unfortunately, knowing that we have those parallel lines, you only get the arcs that are on the inside of the parallel lines. So we need to keep using some more information. The other given information was that we had a diameter. Well, the diameter is going to help us because diameter is creating two semicircles, which means it's creating two congruent arcs. Notice that arc BAC is one of the semicircles. So arc BAC will actually be congruent to the other semicircle arc, which is BDC. And that's also a new reason. That reason says a diameter divides a circle into two congruent arcs. Okay, now we have too much of the arc. Before I didn't have the arc at all, and now I have too much. So what can I do with the two arcs that I now have in my proof? Hopefully you're starting to think that you can use the subtraction property. We can take the arc that I have listed out in green, BAC, and subtract away arc AC, that blue portion, and you'll be left with arc AB, which is the arc I want. So we're going to be subtracting line 4 from line 3. So let's see how that's going to work. Step 5 is going to be BAC, the big arc, and I'm going to subtract away little arc AC. Remember, drop down the congruency, and now take arc BDC and subtract away the little arc BD. That reason, remember, is the subtraction property. Next, we have to take each side of that property. So I'm going to take the left side and say when I have arc BAC and I subtract away arc AC, what do I have left over? And looking at your picture, locate arc BAC, put your finger over AC. What's left? And hopefully you're seeing arc AB. Now we have to go on the right-hand side of step 5 and say when BDC, when I take that arc and subtract away arc BD, what's left? And looking at the picture, you should see arc CD is left. That is the subtraction postulate. And remember, to end these ones, you have to use substitution. So now I can say arc AB is congruent to arc CD by substitution. But again, my proof statement was not about the arcs. It was about the chords. So I need to do one more step. And that step is going to say that chord AB is now congruent to chord CD. And this reason comes from the first proof we did. If two arcs are congruent, then the corresponding chords are congruent. And that ends our proof. We're going to pause there, and I'm going to let you get started on your homework. Your homework for this evening is going to come out of your homework packet, and it's going to be on page 15. It starts on page 15 and it goes to page 16. So you're going to do 4 proofs tonight. Pages 15 and 16, proof numbers 1 through 4. That's all for today. Have a great weekend.